Hello everyone. So in this video we will learn about IPV4 classless addressing. In the previous video we have seen about the classful addressing where we have divided the entire address space into three classes A, B and C, and we have seen that a lot of addresses are actually getting wasted if we follow that mechanism, and even the supernetting and subnetting concept is not very efficient to utilize these addresses. So here is a classless addressing which provides us a way so that we can use these IP addresses in a better way. So let's see here. So this is also called variable length blocking, and we are sometimes calling it CIDR. That means classless inter-domain routing, and here we are free to make block of any sizes. Unlike in the classful addressing, we have the classes where we have network bits 8 or 16 or 24, means we have only some limitations to form our network, but now we can make a block of any size based on our requirement. So here we will be using two terms, prefix and suffix. Prefix is something which is equivalent to network ID in the classful, and suffix is the same which is host in our classful addressing. So here we will be using prefix. This is very important here. So here we can assign any number of bits for the prefix. We are calling it n bits. Like in the classful addressing, the prefix bits will be only 8 or 16 or 24. But in classless, these prefix bits can be anything in the range of 32, from 0 to 32, means it can be 1, 2, 3, 4, up to 32, it can be anything. So here how we are going to represent our classless addressing. So we'll write the first byte dot second byte, third byte dot slash n. That means we can write any logical address using classless in this form. Let's say 120.68.32.9. Let's say this is our logical address. But if we are using a classless addressing, then it is mandatory to specify slash n value. If I write here slash 10, that means my network bits is 10. In the previous case, in the classful addressing, this is not required because we have network bit fixed. It may be 8 or 16 or 24, and we can easily find out the address belongs to which class by looking at this value. But here the network bits are variant, so it is mandatory to write the slash value. Now one thing to understand, the smaller n value means the larger block. If you have this value small, then the block size is more, because then we have more number of host ID bits. What does it mean? It means if I say slash 10, that means network bits will be 10 and the host ID bits will be 22. So means you can have 2 power 22 addresses can be possible in this kind of network. And if I say this size is large, if I take let's say 20, then in that case I have 20 bits for the network and 12 bits for the host. That means in this scenario I can have only 2 power 12 IPs in my network. So when this value is small, you have a larger network size. If this value is more, then you have a smaller network size. This is what this line means. So in classless addressing, it is mandatory that you must know the address along with the slash value. Then only you can get the information about the network. These are some important formulas that are always used to get the network information. So to find the number of addresses in a block, we will be using n equals to 2 power 32 minus n, where this means total addresses in the block, and small n means number of network bits. So by using this formula we can find the size of the network. The first address can be found out by using any address in the network, by using network mask and doing the AND operation. Similarly, for the last address we are using this formula. Network mask we already discussed. I will again repeating this. Network mask means when you keep all the network ID bits equals to 1, then it gives you the network masks. So if you have, let's say, 24.1.2.20 slash let's say 8, this is the information given to you. If I want to find the network mask, that means the first 8 bit I will keep all 1 and the remaining will be 0, will be the network mask. So in this example, this will be first 8 bit will be all 1, that is 255, and remaining is all 0. So this is the network mask for this kind of network. So we will use this formula to find out the information of network. Let us take one example. So this is the kind of address given to us. This is /27, and we are interested to find out the network mask, prefix mask, suffix length, first address, last address, and total addresses. So we are going to make use of this formula. So network mask. So network mask can be find out by using this information. So here network bits is how much? So network bits is actually 27. That means I will keep the 27 bits equals to 1 and the remaining 5 bits equal to 0, and that will give me the network mask. So how can I get these 27 bits? If I have 4 octets I have given to me, then 27 bits means 8, these all ones, all ones, all ones. So this 8, 16, 24 and 3. So here all ones, here all ones, all ones, and here only 3 ones are there, and remaining is 0. 1, 2, 3, 4, 5, 6, 7, 8. So what I get, this is 255.255.255, and if I find this binary number, it will be 224. So this is my network mask. So you can write here network mask is 255.255.255.224. Prefix length. Prefix length is the length of the network bits. So here prefix length is 27. Suffix length is the length of the host bit. So host, you can simply find out 32 minus 27, that is 5. So this is the suffix length. Then I will find the total addresses. So total addresses can be find out by using this formula, n equals to 2 power 32 minus n. So that is 2 power 32 minus 27, that is 2 power 5, which is equals to 32. So total address is 32. Now we need to find out the first address. First address you can find out using this formula. So what we can do is here is, so any address, this is one address given to us, 167.199.170.82, and we need to use mask. So what is the mask? Mask is 255.255.254. So we can apply the AND operation. So we know to do the AND operation, we will be using the lowest value if either of the two values are 0 or 255. So here this is 167.199.170, and here we need to find out that what is the answer for 82 and 224. So how you can find this? So first we represent 82 and 24 as follows. You can see here. This will, so we can write as 82 equals to 64 plus 16 plus 2, and 224 as 128 plus 64 plus 32. And if we want to find out the AND operation, you can easily see that this is actually 64. So this is 64, and this is the first address. We can write here 167.199.170.64. To find out the last address, okay, so now we will see the last address, to how to find the last address. So the last address we can find using this formula. you are now comfortable to find the network information in the classless addressing. So we'll see some more information about the computer networks and IP4 addressing in our next video. Thank you very much.